I'm so happy today because I am in front of the original creator and developer of Clipper. This is Kevin O'Connor. Thank you, Kevin, for being here today. Nice to meet you.
It's great. It's great to meet you as well. Thank you for having me.
We know that the first release of Clipper was in 2016. Could you tell me the story behind this first release? I mean, did you 3D print at that time? Why did you decide to make an alternative software in that age?
Well, it's a good question. It's been a long time now, 7 years since I started the project. It feels like it hasn't been that long, but yeah, I guess it has. So originally, my first 3D printer was I think it was in 2012 that I got it. I had been following along with the RepRap project for many years prior to that. I want to say around 2006 or 2007. I was reading the articles from those involved with RepRap, and I was really excited about it. It was very interesting. My background is in software development, and I'm not the most handy with hardware stuff. I mean, I'm handy around stuff around the house, but I'm not going to build a 3D printer out of spare parts. So when I was first reading along with it, I thought it was really exciting, really interesting, but I thought it was originally at that point was a little bit out of my reach as far as technical side. Around 2011, 2012 is when you started to see these kits come out. And I was really excited. I did a bunch of research and I ordered my first 3D printer at that point. It was a printer made by MakerGear, not MakerBot, but a different company called MakerGear. And all in all, it was a very good printer. And I was really excited to get it. It took me several days to assemble it all, put the kit together and print with it. But I was able to do it and I was able to get out prints. And I thought, I was really excited by that process. Like a lot of people that started off with 3D printing, I had a bunch of frustrations in that process. These are things that, now looking back, were things that we all had problems with when we started with 3D printing. Things like making sure that the bed was level, making sure that all of the settings were correct, the configuration, things along those lines. As I started to get more involved with it and trying to understand how it worked, why was I having problems, how can I make the system work better, I started looking through the software and I started having ideas on, well, there are different ways to do this. One of the first things that occurred to me was how difficult it was to code to the software at that time because they use these very limited microcontrollers, 8-bit microcontrollers. But even whether it was an 8-bit microcontroller or a 32-bit microcontroller, it was still very difficult to code certain algorithms, to maintain the code, to understand the code. My background, as I said before, was in software development. So I was looking at it from a perspective of, well, what could this be done differently on the software side? Along that same time, I started reading up on a bunch of the physical algorithms, the physics that go into the processing of 3D printers. And in particular, I was reading up on how the pressure in the nozzle impacts the print. And as I was inspecting the prints and understanding what was going on, I realized that there were ways that we could change the process. So knowing that and knowing the software, I thought, well, let me go in there and start changing the software. That was the beginnings of what you'd say was pressure advance. Back then, I think they called it something else. I know now they call it linear advance in Marlin and RepRap firmware. There was, I think, different names for it back then. So going through that process, I wanted to change the software. But as I was looking through the software, I felt that, geez, it would just take a lot of work to try and make this kind of a change to the software. And I started, again, thinking about how it could be done differently. And that's what kind of gave me the idea of, well, I could reorganize it and do more of the processing on a regular computer. And the idea behind doing it on a regular computer was I would be able to use more modern programming methodologies, use software that could be more easy to write, more easy to maintain, and in particular, be able to do some of the physical conversions, the physics in regular formulas, and not microcontroller. And that's really what the start of the project was.
Really interesting. And currently, is Clipper composed by a team, several developers, or are you on your own?
So it's an open source project, and a large number of developers have contributed to it over the years. And certainly when you look at the entire ecosystem, that includes things like the front end that a lot of people use, whether that's Octoprint or Mainsail or Fluid. Those are different developers entirely. As far as the core team or something like that, there isn't really a core team per se. I originally started it. A couple other key developers have done quite a bit as well. So a person who goes by the name of ArcSign or Eric Callahan has done quite a bit of work with the web interfaces, with bed leveling and things along those lines. And of course, Dimitri has done a ton of work with Input Shaper and several other developers as well.
Okay, we will talk later about Input Shaper. And one of the concepts I think that is behind Clipper is universality. I mean, you can run Clipper without taking into account the main board you use. Am I right? Can you explain a little bit about this?
Right, and I would agree with that kind of high-level characterization as well. That was one of my primary goals, was I wanted to write the software in such a way that it could be run on a printer without having to write to a particular printer. And that just goes to one of my original ideas, was that really what makes the process powerful is the idea that you're controlling the physics, where the tool head moves, how it deposits the plastic, things along those lines. And whether you're using a stepper motor or a different kind of motor, whether it's a Cartesian printer or a Core XY printer, whether the printer is 8 inches wide or 10 inches wide, whether it's using an 8-bit microcontroller, 8-bit microcontroller or 32-bit microcontroller, these things are really just details. The key parts to success is the physics, knowing where you're supposed to put the tool head, knowing how much plastic is supposed to deposit, and the timing of those moves. So that was a core goal, was to try and write it such a way that the physics came first, and then the details of the implementation came second.
Yeah. And do you think that the increasing numbers of button users has helped to the popularity of Clipper?
Oh, absolutely. Yeah, definitely. The number of printers out there that are using software with Clipper is certainly expanded Clipper. I think you could also argue, if I was to be potentially just a little, toot my own horn, so to speak, a little, one could argue that some of those projects succeeded in part because of Clipper as well.
Okay. And
so in certain ways, Clipper has helped make Voron more approachable. And of course, so many Voron users has helped make Clipper become more popular.
And let me talk a little bit about the financing of your project. As we can see on the internet, some funds came from Patreon supporters, but also I have read the announcement that Big Tree Tech is currently the main sponsor. So is this the main source of incomes in this project?
Yeah, so I never looked at this project as a job. So it's not something that I've done in a goal of making it a career or making it employment. So yes, I do have a series of contributors on Patreon, and I very much appreciate their contributions. And Big Tree Tech has done a spectacular job of supporting the project as well. And I very much appreciate that.
Okay, and how people community can support your project? Only by Patreon.
Yeah, you can support directly, but I don't know that necessarily you have to necessarily donate money to support the project. There are many ways to support the project. Whether that's contributing by providing source code if you're a developer, or answering questions. Yes, there's also a Discord and a discourse server where members of the community help other members, and those are great ways to help promote the project and let people know about how to use it and get involved, and also YouTubers and others as well, spreading the word about it, and having that feedback, I think, is great.
Yeah, I would like to talk about the relation with RAD-RIG company. We know these machines are using RAD OS, which is based on Clipper. So how do you feel when you see that new companies are using your technology as a base to make their business? And also, do they invest some part of the money they earn on Clipper project?
Yeah, so that's one of those things where I think is actually a positive, right? Where you have companies that are working with the software and using it as well. Not only using it, but also helping with feedback and things along those lines. So I am aware of RAD-RIG. I don't have direct interaction with with RAD-RIG. I am aware of the RAD-RIG OS, and I have been in conversations with some of the main designers of that. I think it's a mutually beneficial relationship. We're not in any kind of business relationship with each other, and I don't think that's necessary to be in a business relationship to still have a good relationship with an open source project like Clipper.
Yeah. And if we talk now about the main features of Clipper, which typically are a smooth pressure advance and input shaping, starting with input shaping, have you ever thought about the incredible feature that Clipper has given to the community and also to the companies? I mean, I think it is a game changer for the companies, this feature. What do you think?
Yeah, so these are things where we're being able to look at the physics of the printer and be able to see, if we can change how the software works, potentially you could make the hardware more capable. And that's one of the main reasons that I got involved in the project, was that idea of I can make a printer better by slightly different ways of controlling it via the software. So I think it's great. So the pressure advance, as I mentioned before, is one of those areas where I started on many years ago, and it took several different iterations through it to figure out how to do it in a way that really scales to a lot of printers. So when I first started I didn't even have it. I had released Clipper, but I didn't actually even have the pressure advance part yet into it. I want to say it was a year or so after that I finally got the chance to implement the initial revision of it. And then a couple of years after that is when I introduced the changes which are now in effect that I call smooth pressure advance, which does a better job of controlling that motion even around sharp changes in the pressure that we want within the extruder. So input shaper was definitely a long history as far as development goes as well. We originally started off with input shaper. Well, before input shaper, we did a lot of work with what's called S-curves. And a lot of changes to the code were made trying to support S-curves. When we did all that work, it's interesting because we did it, we implemented it, we ran a whole bunch of tests. I ran a whole bunch of tests on my printers, and I wasn't finding that much of an improvement. In fact, some of the tests I was running, it wasn't an improvement at all. It was actually, you could see the print maybe came out slightly worse. And as we contacted a lot of other engineers and a lot of enthusiasts with their printer, so we had done all this work to implement S-curves, and decided that really it probably wasn't a good thing to add to the main Clipper software. And I want to say it was a good year or 2 years after that where we started looking at slightly different ways to do it. And this is where Dimitri did a ton of work on it. He was able to find other feedback with other contributors. We started looking at input shaper, and Dimitri was able to implement that, not only implement it, but also do all of the work with accelerometers to really get a good feel for not only how to implement it, but what do you configure it to. And then we started to see this huge improvement in prints. I was able to show significant improvements on my printers. We were able to get it out to testers, and a lot of people were coming back and showing really noticeable improvements with it. So that was certainly very impressive from what we were seeing as the results of the printers. And we were good. We were happy to see that go out there and see others be able to use it and see benefit from it. And as far as the commercial aspect to it, I think that's fine for companies to use that. That's it's good to say as a whole. I'd say.
And have you ever considered to make a kind of benchmark for the user to see if the board he's using is capable to manage Clipper in a proper way?
So we do a lot of benchmarks on the boards that we currently support. Most of the time, if the microcontroller that you're using, this is the low-level board and the 3D printer itself, if that can run Clipper, generally it's enough to run whatever kind of printer that you want to run, even the older 8-bit boards. And then there's a second part to Clipper, which is the general purpose computer, which we typically recommend a Raspberry Pi for. Generally speaking, if that machine is capable of running Linux, if it's a Raspberry Pi 2 or later, and in some cases even a Raspberry Pi 0, generally it's enough to run it. There are some cases with a Raspberry Pi 0 where you could overload it, which is why we generally recommend a Raspberry Pi 2 or later. But for the most part, if you have one of those boards, it should run fine. Even with input shaper, even with high-speed printers, those computers are very fast.
Yeah. And also, I would like to know, what do you think about Marlin software? What is your opinion?
So if we go back many years, I used Marlin prior to developing Clipper. And if you look through, if one were to actually go back and look through the software and all the old commits, you'd see that I have a couple of commits in the Marlin source code. So my name is in there. I guess it's probably no secret I prefer Clipper to Marlin.
Surprise.
Yes. I looked at the code many years ago. I decided that I wanted to start something different. I don't think of Clipper being in competition with Marlin. I don't think of Clipper being in competition with the RepRap firmware or any other major firmwares that are out there. I like to think of it as more of an ecosystem where we're all pushing to do the same thing, which is having the best 3D prints that you can get from the hardware.
Totally agree with you. Totally agree with you. In the last years, we have seen how 3D machines have improved a lot in all sense. Overall, in the mechanical part, do you think that the current situation on 3D printing is more related with software development instead of mechanical parts? We have to improve the software instead of improving the building of the machine?
That's a really good question. I'm not sure I've looked at it in that way. I think we've, so if you go back to like 2011 and 2012, I think we've seen a notable number of improvements on both the hardware side and the software side. So I think that's a good question. It's a good question. I would think we're going to see a continuation of both. When I look at the printers today, like so there's a category of printers that are the cube-based printers, typically Core XY, Voron are good examples. Rat rigs also have good examples, and there are several others out there as well, like Hypercube, I think. So that kind of printer really can do an impressive amount of high-speed printing with great accuracy. And I don't think you had that, say, 5 or 6 years ago. At the same time, I think we've seen with the software, faster boards, more accessible boards, that it's possible to move those printheads around at higher speeds that you perhaps could not have done, say, 5 or 6 years ago. So I think in many cases, it's the software has grown to support the hardware, and I think the hardware has grown to support the software. And I suspect we will see. Definitely agree that it's not going to be solely hardware. I think we're going to see that in order to get to that next level, the hardware is going to have more intricate, more advanced software to control it. At the same time, I think the software, software alone can't make a low quality hardware somehow great quality, right? You can only take the process as far as the hardware is capable of handling as well.
Finally, we are reaching the end of this interview. It would be possible you tell me some of the future features which are coming in next version of Clipper?
Great question. So when it comes to Clipper, I can't say that I have any particular grand plans. The software is, it's capable today. It's very capable today, and I don't think that there's anything that's dramatically missing or anything that's on the horizon that's the major earth-shattering kind of thing on the horizon. There will continue to be incremental changes as we go along, and much of the things that we do will be from other contributors that I will be working with and try and review the code and get those integrated into the main branch. If you wanted my high-level thoughts on 3D printing and software in general in the future, one of the things that I'd like to be able to try and take a look at in the future is how do we make the software and how do we make the system as a whole easier to use? So if I take a step, the big challenge that I see is that I find it very difficult. It's easier now to do it than it was, say, in 2011 or 2012, but I still find that it's very difficult. Mm-hmm. If you take a step back and you look at going to the store and buying a two-dimensional printer, which is like a laser printer, an inkjet printer, and you think of that process, you can go to a store, you can bring it home, plug it in, And for the most part, you can have that up and running within 15 minutes or so. You can go to a website, click the print button, and you'll get a picture out of your 2D printer that will look like what was on your web browser. If we compare that to a website with 3D models, you grab one, click print, and then go over to your printer an hour or two later and pick up an object just like what you saw on the website. And I don't think complex, and I would say, possibly unnecessarily complex. So if there are things that I'd like to see in the future of how do we improve 3D printing, it's how can we make it more accessible so that it doesn't need so much configuration, doesn't need so much software to be installed, doesn't need so much work to be done just to get to that first print. And then, of course, there's that second part of anyone that's used a 3D printer knows that prints fail from time to time. And I think that's kind of normal. But one of the challenges that I see is if you get a failed print, how do you figure out why it failed? And that I can, from my experience, that can take hours, days to try and figure out what went wrong. And that's another area where, again, if I were to step back and say, how can we improve 3D printing in general would be how can we figure out when something goes wrong to try and explain to the end user why it went wrong and what steps they need to make it work better in the future.
Okay, Kevin, so I know you are a really busy person, so thank you so much for your time and for this interview. I'm so happy to be here today, and thank you so much. See you soon. Bye-bye.
Thank you very much.